Hi everyone, we're Agua Clara AIDE Code. We are a part of the Agua Clara Infrastructure Design Engine. So what is the Agua Clara Infrastructure Design Engine? Basically the main problem that we're trying to solve is that Agua Clara, we have a lot of different communities that we are trying to help, and all of these communities are of different sizes. And basically we are trying to help make plans for all of these different communities, and we are trying to create 3D models to fit into these different communities. So how does AIDE work? AIDE allows us to automatically redesign water treatment plants, to redesign the water treatment plants. And we take in a single variable, which is flow rate, and then we run calculations based on the flow rate, and then these 3D models are designed based on the calculations that we do. AIDE functions as a set of interconnected modules, each of which serves basically a different role. Data is passed between the user's computer and between the cloud-based internet services. In the cloud, we are using Onshape and FeatureScript to build 3D models. That is the side that we're on. We're using FeatureScript to create the 3D models, and Onshape is a 3D servicing model that helps to do that. And FeatureScript is the language that helps to do that. And on the computer, there are two very important Python packages that communicate with these 3D plant designs. So as code, our main goals is to help AIDE template create any functions that they need. There's a lot of repetitive functions that they have, and our goal is to just make it that they can do this with the click of a button. This semester, our goal was to create a function that would put elbows anywhere there were 90 degrees angles, and to split this into two different parts. So the first part, two of us were working on to identify the 90-degree angles and then put in the elbow at the correct orientation. And the second team, the rest of us were working to measure the distances that we needed to trim off the pipes before we inserted the beams into the elbows.
Okay, so what we're using to code in Onshape is FeatureScript. Basically, FeatureScript is a programming language developed specifically for Onshape. It's used by Onshape developers to code already existing functions like beam or line or all the other things that come with Onshape. And we're using it because it's open source and it's the best way to make everybody's lives easier. So if we code a function in FeatureScript now, basically anyone can take that function and use it for themselves, and anything that other people code we can use too. So in the future, hopefully, as Onshape develops more and more, we can take a lot of functions from online and make our lives a lot easier. So FeatureScript has its own library of functions. As you can see in this picture, there's a whole standard library documentation page. We actually use this heavily because FeatureScript has a lot of functions, and each of these are really specific and apply to like a very niche thing. And that's actually one of our main difficulties, because we think that we find something that can apply to our code, but then when you actually try to apply it, you find out that it doesn't really work. Say like it takes in a query and you need to return like something else, and it doesn't work half the time. But this does simplify the CADing process, because after we do code it, things can be done with the click of a button. So in this picture, you can see that we have the beam function, but as you do more and more and create more features for it, new boxes pop up at the bottom right here, and when you click on them, they do the whole entire function by themselves with one button.
So currently, our main goal for the semester is to create the elbow function. This, as Mitch explained earlier, will be split into two parts. The first one is to find 90-degree points and insert an elbow in the location. And the second one is to trim the existing beams and orient the elbows properly. So in order to decide where the elbows are going to go, we created a helper function known as find points to find 90-degree angles within a selected amount of points. This also utilizes a FeatureScript and Onshape entity known as paths, which is just a collection of lines that are connected together in order. So by orienting all of the lines to go in the same direction, as well as connecting them together in a path, we can find the angles of all the all adjacent lines, and if the angle is 90 degrees, we can put that into an array. As you can see in this image, the 90-degree angles are highlighted with red dots, and those will be returned as an array to go into our other functions as locations for elbows. So the second helper function we created is an instantiator, which is another feature script entity that allows us to export and import other part studios and other sketches, other models, etc. So in this case, we will take the array of points from earlier, and for each location that was highlighted red in the last slide, we'll insert an elbow using this instantiator and center it at that point, which will allow us to set up for the future groups to trim the existing beams and then rotate those elbows into place to finish our function. So we've been heavily using the forums to connect with other feature script users and also get a lot of our questions answered. We've recently been able to get in contact with a lot of Onshape professionals that work for Onshape, and not only do these people have an excellent grasp of feature script and understand the language and can answer our questions, it also helps us integrate into the community better so that we can become part of the Onshape community, and future AIDE code and just Agua Clara in general can be very integrated into the Onshape universe as it expands and develops more.
So once the elbows are placed between all perpendicular beams in the structure, we want to actually trim those beams so that they fit into the elbow appropriately. To find the length to trim on these beams, we actually want to find the distance between the origin of the pipe and its mate connectors. Mate connectors are coordinate entities that both orient and locate two parts with respect to each other. So once we find that distance, that'll actually give us the length that we need to trim on these pipes so that they fit into the elbow appropriately. The code I have written here is basically a function that both gives us access to perpendicular beams, as well as lets us use the length to trim. So basically, it allows us to, given an origin of a pipe, if you click it, it'll access both pipes, given an elbow's origin, it'll access both beams perpendicular to that elbow and allow us to trim the appropriate length. So the way we were actually able to find the distance between the origin of the pipe to the mate connectors was using an Onshape function that was already made by Onshape. It basically measured the distance between any two entities. The only problem was that you weren't allowed to select a mate connector as one of these entities, so we actually had to go back into the Onshape code and debug a little bit. We basically added the body type of a mate connector to be in both entity type filters, and that was all we needed to do to fix that issue. This was really awesome for us just because the measure function is well written. It was already made by Onshape, and we could implement in our code very well. It flowed naturally, but initially we actually tried to access these distance values through what are called configuration tables. That was just a big problem for us because we couldn't access these values very well. It's really used only in CAD and design. It's not really used in code, so this measure function just helped us out a lot because it basically formalized what we wanted to do in code and allowed us to write our original function that I showed previously very well. So, thanks.
So some difficulties that we encountered throughout the process. In the beginning, we were all new to FeatureScript. We had never used this language and this type of language before. So it took us a while to get accustomed to all the syntax and everything. Another thing that was really difficult was that fact that Onshape is new and FeatureScript is new. It was created in 2016, and so basically there's like a lack of community, like when we're using Python, we can go online, we can type in any problem we're having, and there's always code and documentation out there to help us. But with FeatureScript, there is nothing that exists. So all the questions that we had, we have to go onto the forum and ask personally. And oftentimes the answers that we got weren't exactly solving our problems, or we didn't get the type of help that we wanted. So it took us a lot of time to get used to the language and to get used to the type of help that we were used to.
Okay, so in the future, we will code a lot more functions that template requests. So right now, we coded the beam function, not the beam, I'm sorry. We coded the elbow function, we added all the functionalities, we did that stuff. In the future, there's some bugs, and we have to finish implementing the trim and combining the functions to actually fully implement it. But for the most part, it's done. But in the future, this is our life. So we have the improved linear spacing function that is already requested that we will hopefully finish by next semester. And there's also a lot more functions that they will request in the future because they do a lot of repetitive things that we can make easier by just coding a function up and then clicking a button. But that will be up to them, as this question mark says. It's whatever they desire, not us. For future teams reference, it's really useful to make heavy use of the forums and to understand the syntax of language before you start coding. Because so many things are really specific, it's really, really good to get a general grasp of what you can do before you start. So thanks for watching, guys.